Dear students, welcome back. Today we are dealing with some application problems of projection of lines. In this type of problems, some situation in the field or some object will be described. Its relation with ground or horizontal plane and a wall or some vertical object which implies vertical plane will be given. Indirectly, information regarding front view and top view of some line or lines inclined to both reference planes will be given. And we are asked to draw its projections and determine its true length and its inclination with ground. Here, our first problem is two objects, a flower A and an orange B, are within a rectangular compound wall whose P and Q walls are meeting at 90 degree. Flower A is 1 meter and 5.5 meter from walls P and Q respectively. Orange B is 4 meter and 1.5 meter from walls P and Q respectively. Drawing projection, find distance between them if flower is 1.5 meter and orange is 3.5 meter above the ground. Consider suitable scale. Here the dimension given are in meters, so we have to use a reduced scale for drawing this one in a piece of paper. Now we can solve this problem starting from XY line. An observer is looking from the top can see the wall P and wall Q as two lines. These lines can be marked at a convenient distance below XY line because we are now dealing with the plan of the compound wall. Now at any convenient distance we can draw wall P and wall Q which is 90 degree with wall P. Now we have the distances of flower A. This flower A is considered as point A and orange B is considered as point B, and the distance of this point A is given as 1.5 meter and 1 meter from wall P and Q. So from wall P the distance given is 1.5 meter and from wall Q the distance given is 1 meter. So this intersecting point of these two lines will be the point A. Now we have the distance of point B, that is the position of orange, from horizontal and vertical wall as 3.6 meter and 5.5 meter. Now I am marking 3.6 meter from wall P and the 5.5 meter from wall Q. This intersecting point will be the point B. Now again join A and B. That will be the plan of the line joining this flower and orange. Now we know A and A dash will be on the same vertical projector. So through A I am drawing a vertical projector and height of the flower is given as 1.5 meter from ground. So marking 1.5 meter and getting the position of point A dash. And we know B and B dash will be on the same vertical projector. So I am extending the projector in the upward direction through B, and the height of the orange is 3.5 meter above ground. So marking 3.5 meter from XY line, I will get the point B dash. Now the line joining A dash B dash will represent the elevation of the line connecting with flower and orange. Here we are asked to find out the distance between them. that is the distance between flower and orange. That is, we have to solve for the true length. For getting the true length, I am rotating the plan and making that one horizontal and projecting it upward and meeting the locus line of B dash. Now this intersecting point is B1 dash, and now I am joining A dash B1 dash. That will be the true length, which is the required answer in this problem. Now we can move on to the next problem. The two mangoes on a tree A and B are 1.5 meter and 3 meter above ground, and those are 1.2 meter and 1.5 meter from a 0.3 meter thick wall, but on opposite sides of it. If the distance measured between them along the ground and parallel to the wall is 2.6 meter, find the real distance between them by drawing their projections. Here, the wall can be represented by a rectangle in the elevation. Okay. The mangoes A and B on the tree are considered to be the two ends of a straight line AB. And the position of end point A is 1.5 meter and position of end point B is 3 meter above ground. So from XY line we can mark point A at a height of 1.5 meter. That is, from ground I am marking 1.5 meter in a suitable scale and locating the point A dash. Now the point B is 3 meter above ground. This line, which is 3 meter above the XY line, will be the locus line for B, but we don't know exactly what is the position of B. So now we are going to extend the vertical projector in the downward direction. Before that, top view of the wall is marked at a convenient distance below XY line. So the position of point A is 1.2 meter from thick wall and position of point B is 1.5 meter from the thick wall in the opposite direction. So here this will be the point A, and the distance between point A and point B along the ground and parallel to the wall is 2.6 meter. Means it is the distance between end projectors through A and B. So this point will be point B. Now I can join A and B. That will be the plan of the line joining A and B. We know B and B dash will be on the same vertical projector. So I can extend the projector through B in the upward direction and getting the intersecting point at 3 meters above XY line. So that point will be B dash. Now I can join A dash B dash to get the front view of the line AB, which joins point A and B. Now we have to find out the real distance between A and B. For that I can rotate the line AB and made it horizontal, and then it is projected upward to get the intersecting point B1 dash. A dash B1 dash will be the real distance between the mangoes A and B. Okay, now the solution is over. Here we have the third problem in which the size of a room is given. L, D and H of the room are given. L is 6.5 meter, D is 5 meter and H is 3.5 meter. An electric bulb hangs 1 meter below the center of the ceiling. A switch is placed in one of the corners of the room, 1.5 meter above the flooring. Draw the projections and determine the real distance between the bulb and switch. Here we have the bulb which is hanging 1 meter below from the center of the room, and the switch is located at one corner of the room. We have to find out the distance between this switch and bulb. Now we can solve this problem. Here, first of all, we have to mark the plan and elevation of the room. The height of the room is 3.5 meter. The width of the room is 6.5 meter. So an observer looking from the front of the room can see a rectangle like this as the elevation of the room. And an observer looking from the top of the room can see a rectangle like this, having dimension 5 meter and the width 6.5 meter. Here, a bulb hangs from the center of the ceiling. So, an observer looking from the top can see this bulb as a point at the center of the room. And in the elevation, we can see the bulb is located 1 meter below from the center of the room. So, I am marking point B dash, which is 1 meter below the center of the room. Now the position of the switch is considered as point A, and the switch is 1.5 meter above the flooring. So from this corner 1.5 meter above, I am marking point A dash. Now A dash B dash will be the elevation of the line joining the switch and the bulb. Now an observer looking from the top can see the point A. Here I am marking the point A in this corner. Now I am marking the center point of the room in the plan here, and this point will be the point B. Now I can join point A and B, which will represent the plan of the line joining the switch and bulb. Now we have the elevation and plan. You are asked to determine the true length of the line joining A and B. For that, we have to rotate the NB, made it horizontal, and then I can project it upward to get the intersecting point on the locus line through B dash, and that intersecting point will be B1 dash. Now I can join A dash B1 dash, which will represent the true length of the line which connects switch and bulb, which is the required answer. So A dash B1 dash can be measured for the real distance between switch A and bulb B. Okay, now we can move on to the next problem, problem number 4. Here, a pipeline from point A has a downward gradient 1:5, and it runs due east-south. Another point B is 12 meter from A and due east of A and in same level of A. Pipeline from B runs 20° due east of south and meets pipeline from A at point C. Draw the projections and find length of pipeline from B and its inclination with ground. Here, the dimensions are given in surveyor's unit. So you should have an idea about the surveyor's unit. Now we can solve this problem. Here, first of all, start from XY line. Above XY line we can draw the elevation and below XY line we can draw the plan. So we have to mark north in the upward direction, south in the downward direction, west in the leftward direction and east in the rightward direction. And this intersecting point can be named as the point A. That is one end of the pipeline 45 degree from south. We can mark the direction due southeast. I am going to mark a line which is 45 degree inclined towards east direction. I don't know exactly what is the length of the line. So I mark just a line from point A in the 45 degree. Another point B is 12 meter from A and due east of A and in the same level of A. The level difference will be always visible for an observer looking from the front. So in the elevation we can mark the same level for A dash and B dash. A dash will be on the same vertical projector through A. At a convenient position we can mark point A dash and at a distance of 12 meter going to mark point B dash. So A dash B dash will be like this. Now we know B dash and B will be on the same vertical projector. So the point A and B will be obtained like this. The direction of pipeline B is 15 degree due east of south. So from south 15 degree is marked in the eastern direction for marking the direction of pipeline B. So I am marking a line which is 15 degree from south direction towards east direction, and this intersecting point of line through A and B will be the point C. Another data given is the slope of the pipeline from A, that is 1:5. So I am marking 5 units in the horizontal direction and 1 unit in the vertical direction, and joining these endpoints I will get the slope of the line. Now I am extending this slope of the line through A, in which I can mark the true length of the pipeline. The true length of the line is not given. I am going to rotate this AC and making it horizontal and projecting it upward, and this intersecting point will be the C1 dash. And A dash C1 dash will be the true length of the line, and through C1 dash I am drawing the locus line for C dash. So this point C and C dash will be on the same vertical projector. So I am marking a vertical projector through C to get the intersecting point on this locus line, which will be C dash. Now I can join A dash C dash, which will be the elevation of pipeline AC, and if I join B dash C dash, that will be the elevation of pipeline BC. Here we are asked to find the length of the pipeline from B and its inclination with the ground. The length of the pipeline B to C is the required answer. For that I have to rotate this BC, that is rotate this point C with respect to B, and then it is projected in the upward direction to get the intersecting point C2 dash. Actual length of the pipeline BC is represented by B dash C2 dash, which is the required answer. And the slope, actual slope of the pipeline BC will be angle theta, which can be measured from the projection. Now we finished the solution, and you can try similar real life problems. Okay. Thank you.